look at what is needed in the Indian context with regard to taking forward these innovations. Where we are is at the prototype stage largely, and even in this stage, we need more of our university labs to step in. Some research labs like SET have been able to create these prototypes, but then our university labs are nowhere near in terms of technology expertise as well as human capital expertise to create these products. We need a lot more of this coming into our system, and biomedical engineers and students like you need to be the driving agents with regard to building this capacity for us. Second, if we look at the next stage, a key component to doing a lot of this testing and creating more of the products is with regard to finance. And what we have now is largely funds from the Department of Science and Technology, which is a government institution, which is giving in a lot of these funds for doing this testing. But then this cannot really be there at all times. So we need risk capital, which could be from angels and venture capitals and sources like that, which can really push us to the next frontier for commercializing more of these innovations, not just for COVID, also going forward within the Indian context. Third, if we look at it from the approval side, where do we get a lot of these approvals today? In India, a lot of these approvals are now going into the Drug and Pharma Authority. You might naturally ask me a puzzled question as to why is drug and pharma looking at product innovations? Clearly, that's two different ballparks, right? So in that regard, we need a product innovation specific regulation authority for India, which can look at it purely from the technology side of these products and regulate these products and kind of have approvals around that. So we need that also to help us with the commercialization aspects. And finally, when we look at it from the buyout and product launch point of view, again, we need a lot of you to really step up by creating startups which will take up the technologies that is coming up from the research labs, because research labs have the limitation where they are into research and prototyping. I mean, they do not have the bandwidth to commercialize these things. And startups need to come in to commercialize the technology that is coming out from our research labs. And we also need biomedical specific incubators to help support the startups that are going to commercialize, because India doesn't really have that much of expertise as a lot of the Western countries have with commercializing products for the medical innovation. So it's important that we also create the support system, create the startups to help the commercialization of technology. And here again, we need biomedical engineers, students, and then startups to really fill in the gap and build and bring in your specific expertise that you have built from your engineering and other sort of background to help us with these innovations. Another agenda for us going forward is that right at the university level, we need to have multidisciplinary teams working together on projects. What do I mean? Let me give you an example from what I am doing at Strathclyde Business School in the UK. So we have a course called Enterprise VIP. And what happens in this course is that we bring together engineers, business school students, humanities students, economic students, and put them in a joint team. And for the prototypes that are developed in the engineering departments, we get our business students to provide a business model or a commercialization technology plan and things like that. And we get the humanities students to think about from the customer's point of view, think about it from the social policy point of view and things like that. And so when we have these diverse multidisciplinary inputs coming into the project, it makes the output of the project more wholesome and also make it more ready for commercialization at a faster pace. Some of the examples is what I have put in this. There are in the last year we had projects like solar e-cookers and water desalination, solar-based product in Sundarbans Delta in West Bengal. So some examples, but then the important point is the multidisciplinary input that's coming into these projects. Then we also need, in the Indian context, a health innovation ecosystem transition. I'm not saying that we need one or the other, we need both, but then we need both to be of equal quality. What we already have is a good hub around vaccination and pharma and biotech, given companies like Biocon, Serum Institute, and all of them. And they have been pushing the Indian frontier from the vaccination point of view. And India is one of the largest exporters for all of these vaccines, as you might already know. And even Serum Institute is now hopefully going to be the lead exporter for the COVID-19 vaccine, if the vaccines that they are currently under testing is what is going to become the COVID vaccine, for instance. But then if we look at it from the medical product innovation point of view, we are still a net product importer. But we need to build our capacity on this front. And we are beginning to see good promising signs on this regard in the COVID situation. We are seeing startups like MyLab, we are seeing incubators like CCamp, and people like that coming together to create medical products. If we can build on this expertise that we are developing now around the COVID situation, we can become a local manufacturing hub for medical product innovations going forward. And biomedical engineers and innovators like you are going to be at the forefront of leading these innovations for us. So there again, we want you to take the charge and push us forward on this regard. Finally, there is a lot of scope for Indians to bring in their what I call frugal jugaad innovation approach and put it along with new and existing innovations that we have to create indigenous medical device innovations for the Indian context. Let me give you an example. If we look at the ventilator example that we discussed earlier, ventilators has been around for a while. So ventilators by itself is not a new innovation or like that. But then what's been new with that in the Indian context is the fact that we are customizing and contextualizing the innovation for the Indian context, especially the rural Indian context. So if you look at the aerobiosis ventilator, it's a low-cost ventilator. It is so it's affordable to the rural masses. It is portable, so you can carry it around to even the rural areas and things like that. And third, it works with battery-supported technology. So you can put in lithium-ion batteries to operate it, so that you can operate it in conditions where electricity services aren't really that great. So when we put these things in combination, we have an indigenized version of an existing technology, or it could also be new technology, which will really drive us with regard to pushing the boundaries for local innovations in the Indian context. We are seeing people like the sort of organizations like National Biomedical Research Indigenization Consortium really pushing forward a lot of these innovations. We also have the Makers Asylum bringing together innovators to create frugal innovations like this. We need a lot more of this, and again, people like you need to really push us with regard to these innovations. And once we have these innovations, we also have the possibility to reverse knowledge transfer, or what's also called reverse innovation, wherein the indigenized versions of this technology could easily be taken over to, let's say, other emerging markets in Africa where similar constraints are there for these innovations. It could even be taken to developed markets like the Western world and given over there. So we need all of this really coming forward from innovators like this to push us with regard to